Good morning to everyone. Have any doubts in the last session?
Sir, good morning, sir. Your voice is low, sir.
Do you have any doubts in the last session?
Sir, yesterday you gave an homework, no sir, that how to reverse that integers that you can explain now. Sir.
Yes, yes. Have you solved that?
No sir, I am not getting idea about that. Sir.
Okay. Now in this session, we focus on how to reverse the given digit, and then we focus on write GCD and some other algorithms. Then we will focus on how to write implement these algorithms in a C language. That is the focusing. Uh, Check right voice is audible.
Yes sir, audible.
Okay, I am sharing the screen. First, let us see how to reverse the given positive integer. Reverse the given positive integer. Say n. In the last session, we have devised a logic to find the sum of the digits of the given integer. Suppose n is equal to 1, 2, 3, 4, 5. We have initialized sum is equal to 0. Then we have performed modulus 10 operation to extract the digit 5 first. 5 is the unit digit. After extraction of this unit digit 5, the variable s gets updated. S is equal to 0 plus 5, that is 5. Then the variable n is changed to 1, 2, 3, 4 by performing the operation n is equal to n division 10. That means the integer division, we are considering the quotient only. So 1, 2, 3, 4, 5 division 10 becomes 1, 2, 3, 4. Since now n is equal to 1, 2, 3, 4, if we do the operation mod 10 operation iteratively here, we can find the next digit, for example 4. S is equal to 5 plus 4 is equal to 9. Then n is equal to n by 10, this is carried out. Iteratively, these operations are continued until what is the condition? N greater than 0. We need to perform these operations iteratively. Finally, printing the value of s, we have got as 5 plus 4 plus 3 plus 2 plus 1. This is equal to 15. 5 into 6 by 2. 30 by 2, 15. In this session, we focus on how to reverse the given positive integer. Suppose n is equal to 1, 2, 3, 4, 5, from which we need to get 5, 4, 3, 2, 1. So the logic rate, this is similar to the previous one, how we have carried out the modulus 10 and the division 10 operations. Similar to that, we need to make little bit modification so that the digits can be reverted. Please check here, n is equal to suppose 1, 2, 3, 4. Take a 4-digit a positive integer. First, if we perform the modulus 10 operation, suppose n is equal to n mod 10. N is equal to n mod 10 means right, the value 4 is stored in the variable n. n gets updated. Thereafter, right, the original value of n is lost. So what we have to do, I am updating in another variable, say s. S is equal to n mod 10, provided s is equal to 0 initially. So if we write s is equal to s plus n mod 10, what happens? 1, 2, 3, 4 modulus 10. This results in 4. So the integer 4 is assigned in the variable s. Next stage, we need to extract the digit 3. How to extract the digit 3? That is the question mark. After this extraction, how do we bring 3, 4 to 4, 3? That means having currently one digit 4, its reverse is 4. Please understand, currently we have one digit 4, its reverse is 4. First tell me, how do we extract the digit 3? How do we extract the digit 3 next? N should be performed n by 10. This stage n is 1, 2, 3, 4 by 10. Quotient is 1, 2, 3. So the integer 1, 2, 3 is obtained. Then if we perform modulus 10 operation, 123 mod 10, the integer 3 is obtained. Okay, now here the important thing is we need to store the result again in the variable say n or in some other variable s. In that case, after the extraction of digit 3, those to have two numbers. One is 3, another one is stored in the variable s 4. From 4 and 3, how do we bring a 43? That is the question. From s is equal to 4 and this modulus result, the modulus results in 3. How do we bring 43? For that, right, I am multiplying this s by 10. That means current s is multiplied by 10, s into 10 plus I am performing this operation n mod 10. So that what happens, I am evaluating here, current s is 4, 4 into 10 plus n mod 10 is current n mod 10. What is the current n mod 10? After the update, n is equal to n by 10. 4 into 10 mod t plus 3. This is changed to 43. So previously we have one digit 4, its reverse is 4. Currently we have extracted two digits 3 and 4, its reverse is here 43. Next, we need to extract digit 2. To extract digit 2, again perform the same sequential operations. N is equal to n by 10. Current n is 123. When 123 is divided by 10, we get the quotient, right? 12, not 12.3. Quotient is 12, remainder is 3. From this 12, right, we need to extract digit 2. So I am performing this arithmetic and to update in the variable s. So I am writing here s is equal to s into 10 plus n mod 10. Even initially here, actually, this is s is equal to s into 10 plus n mod 10. Hope you understand. Since initially s is 0, 0 into 10, 0 plus n mod 10, right? There is no change. A 4 is held in the variable s. Now evaluating the same assignment statement or a well-defined instruction with respect to our algorithm, s is equal to s into 10 plus n mod 10. what happens? Current AC is 43. This one 43. This is multiplied by 10. Then n mod n. Current n is 12. Current n is 12. Performing 12 mod 10. 43 into 10, 430 plus 12 mod 10 is 2. So we have the result 432. So having right the last three digits 1, 2, 3, 4 here, sorry 2, 3, 4 here, we have its reverse in the variable s. S is equal to 432. Current n is 12. Next 12 needs to be performed the same operation. N is equal to n by 10. Current n is 12. What is S? S is 432. Is it? Current n is 12. S is 432. Next, performing our iterative operations. N is equal to n by 10. This means n stores 12 by 10, not 1.2, instead 1 as a quotient. Then updating a variable s is equal to s into 10 plus n mod 10. Current s is 432. 432 into 10 plus current n is, what is the current n? 1. 1 mod 10. This is 4320. What is 1 mod 10?
1.
What is 1 mod 10? Yeah, 1. We have already stated the equation x mod y is equal to x. If x is less than y, the dividend is less than the divisor, then the dividend is the result during the remainder operation. So this results in 1. Adding this, we have obtained 4321, which is stored in the variable s. This is the reverse of the input integer n is equal to 1, 2, 3, 4. So we understand the logic. We need to perform repeatedly the operations n is equal to n by 10 and n mod 10 and updating the variable s, so that finally the reverse is stored in the variable s. Clear?
Sir, is there any other way to solve this question?
Any
Sir,
other
using
way? Actually,
for
right?
loop we can do no, sir.
Yeah, you can use the for loop also, right? Now we are going to design the algorithm, right? Using right for loop or while loop. So whichever is convenient, right? You can modify it. But there are several ways for your question. Once you discuss the concepts in C language, say array structures, right? You can also extract the digits one by one and store it in the array, individual array locations, and you can print. That also right results in that appearance 4321. So as of now, I clearly said that I need the result in some other variable. For example, in the variable yes. So once we input n is equal to 1, 2, 3, 4, finally we need to print the result in the variable say yes. Yes needs to be obtained as right 4321 as a reverse of n. Now let us devise the algorithm. Step 1. What is our algorithm? Algorithm name is reverse of a positive integer. Let us write the steps, right? As usual, the well-defined instructions are going to be written here. Okay, step 1, start. Step 2, we need to think of our input, right? we need to input, right? Only one positive integer is n. So input the integer, input an integer n, n is greater than 0. Step 3, what to write? Please think of how do we have designed sum of the digits of the given integer. That we used the variable s to find the sum of the digits. Here also, right, for example, I used a variable s, or you can use a variable r to indicate its reverse, or you can use the variable reverse, REVERSE, whatever is. Here I used a variable s, so we are initializing the variable s to 0. S has been set to 0 initially. Then step 4, just to think of how long we have carried out these operations. That is important. N is equal to 1. Next stage, if we perform n is equal to n by 10, the result is, right, 1 by 10. 1 by 10. What is 1 by 10? With respect to the integer division, what is the quotient?
0.
0.
0.
Good. So when n is greater than 0, or we can say as long as n greater than 0 remains true, we need to perform these operations. So I am making this as the entry condition into our processing. So shall we write here while n is while n is greater than 0, here we can write, right, perform the steps or execute the steps. Sorry, perform the steps. We will it later. Then step 5. In step 5, we need to update the value s first. As we discussed here, after setting s is equal to 0, everywhere we need to use the common assignment statement. S is equal to s into 10 plus n mod 10. Here s is equal to s into 10 plus n mod 10. Here also s is equal to s into 10 plus n mod 10. Initially, right, here also, right, later I modified, I said this s is equal to s into 10 plus n mod 10. S is equal to s into 10 plus n mod 10. So I am writing that equation here. Let us verify, right, after writing this algorithm. S is equal to s into 10 plus n mod 10. This is one well-defined instruction to be executed when the while condition is true. So I put some indentation here, or here we can use the steps while n greater than 0. Then step 6, after the update of s, what needs to be updated? The variable
N by 10.
n needs to be updated. N is equal to n by 10. Have a look into here. N is equal to n by 10. Here also n is equal to n by 10. Even the last stage, n is equal to n by 10. So writing this as a well-defined instruction, I write here in this step, step 6, n is equal to n integer division at 10. If you want, you can use like semicolon at the end. That is not an issue, right? Not necessary. These two are actually part of our while loop processing. That means what we can say in the pseudo code, Perform the following operations as long as n greater than 0 remains true. Or in a simple English statements, step 4 can also be written as repeat steps 5 and 6 until n greater than 0 becomes or n greater than 0 is true. Or you can say in another way, repeat steps 5 and 6 as long as n greater than 0 remains true, whatever is. Or you can write while n greater than 0, perform the steps 5 and 6. So whichever is right, repeat steps 5 and 6. That means as long as n greater than 0, right? Whichever is, you can write as long as n greater than 0 remains true. So these are the part of while block statements. After this, step 7, we need to print the value of this. So indentation, right, with respect to W column, here I write print yes, then step 8, stop. If you need, you can write the 9th step to terminate the process by calling the end statement. These are the well-defined instructions in writing the algorithm to reverse the given positive integer. Once the algorithm has been written, we need to ensure its correctness. That means the algorithm should produce the correct result for all valid inputs. How do we check? I clearly said, right, in the previous examples, try to construct a tabular format in terms of some columns so that you need not write these steps as I have defined in these are traced in these slides. Again and again, right? Why do we write unnecessarily n is equal to n by 10, s is equal to s into 10 plus n mod 10, checking that it is an n greater than 0, right? Unnecessary operations. So try to
Sir,
fix the necessary call. Yes,
uh, sir,
yes, tell me.
I have a doubt with this pseudocode, sir.
Yes,
Sir, for 1, 2, 3, 4 only we are doing this, no, sir. This
thought.
to reverse the number into backwards, no, sir. That's what this code is for, no, sir.
Yes,
Sir, when we are doing it, sir, like for example, 1, 2, 3, 4 only. Finally, when it comes to 12, sir, the step number 6 will make it as 1. Then when it is going back to step number 5, 1 mod 10, it cannot be divided, no, sir.
right. In the first session itself, Vasudha Ji, right? In the
Yes,
first
sir.
session itself, I have explained what is the modulus operation.
It's the remainder,
Dividend
sir, but
divisor, yeah.
if it cannot be divided, how can there be a remainder, sir? That was
Which one? Which
for
one?
step 5.
N is equal
No,
to,
sorry, sir, I
yeah,
got my
1 minute,
mistake.
step 5,
Sorry,
got
sir, sorry,
clear?
sir, I got my mistake. Yes, sir.
Okay, it's okay, no problem. You just try to please remember the modulus operation carefully. So that's what I have written. Two equations, right? X mod y. X mod x is 0, x mod y is x when x is less than y. So try to remember those equations carefully and perform the modulus and division operation. So do not confuse, no problem. This is modulus remainder 1. This is quotient integer operation. It's okay. Now let's do the trace right for one value of n so that you will get a clear understanding how these instructions are executed so that you can easily remember these well-defined instructions in your mind. So I'm taking one value n is equal to say 5672. Let us fix the columns right with respect to the algorithm. It seems right n greater than 0. One condition column is necessary. I put n greater than 0. This is one column. Then s is equal to s into 10 plus n mod 10. S is equal to s into 10 plus n mod 10. It is enough to fix right the minimum number of columns. You need not extend right s into 10 n mod 10 in two different columns. Then another operation as insert in step 6. Hope you understand. Step 4, step 5, step 6. These are our major operations. N is equal to n by 10. For all tracing, the first row, first write the initial values. Initial value of n is, right? I am writing this here as 5672. Without the right hand side evaluation, I am writing the initial value of s as 0 since we initialized it in step number 3, s is equal to 0. Then the value of n, right? Once again I write 5672. This is initial stage. Okay, come to step number 4. While n greater than 0, we need to perform the steps 5 and 6. So check if n is greater than 0. 5 greater than 0, condition is true. So I put a tick mark. N greater than 0, condition is true. Then evaluate s is equal to s into 10 plus n mod 10. I am writing only the right hand side evaluation. It seems whatever the value is returned here, this is the value of variable s. So s into 10, current s is 0 is taken 0 into 10 plus n mod 10. N mod 10 is 5672 modulus 10. So this results in the integer 2. This results in 0, 0 plus 2, 2. So please understand that this 2 is stored in the variable s. So I need not write s is equal to 2. Then n is equal to n by 10. In step number 6, 5672 by 10, not 567.2, but 567 integer value. Next, control enter into the step number 4 since we have mentioned that repeat steps 5 and 6 while n greater than 0. 567, this is the updated value of n. This is greater than 0. Yes? Any doubt?
Again, sir.
Yes?
Sir, can you repeat it again, sir?
Okay. I start from the beginning. N is 5672. We are constructing the necessary columns as we formulated in the steps 4, 5 and 6. Step 4, step 5, step 6 are formulated as the columns. Then first write the initial values. N is 5672, S is 0, N is 5672. These are initial values. Please understand, control enters into step number 4. That means we are repeating the operation mentioned in steps 5 and 6 while n greater than 0 is true. Now check n greater than 0. N greater than 0 condition is true, so I put a tick mark here. Then S is evaluated as S into 10 plus N mod 10. Current S is 0. This is taken. I have written here 0 into 10 plus N is 5672. This one 5672 modulus 10. The remainder is 2. 2 plus 0 2. So S gets updated to 2. Then N is divided by 10. 5672 by 10 results in 567. Then control enters into the while loop while n greater than 0. What is current n? 567. Okay, I write here 5 is visible 567. This is greater than 0. Greater than 0. Then S gets updated. What is the current S? Current S is 2. So we need to use this 2 here. 2 into 10 plus n mod 10. N is 567. 567 modulus 10. This is 20. Here the remainder is 7. 20 plus 7. 27 is updated in a variable S. Understand? Are you clear now?
Yes, sir. Yes, sir. Thank you, sir. Okay, thank you, sir. I understand, sir.
Good. Okay. Then n is equal to, this is n by 10. Okay. N is equal to n by 10. Current n is 567. 567 by 10. This is not 56.7 but 56. Then check if 56 is greater than 0. Condition is true. Perform this operation. 27 into 10 plus 56 is the current n modulus 10. 27 into 10, right? 270 plus here modulus 6. We have got 276. Then 56 by 10, this is 5, not 5.6. Again, 5 is greater than 0, condition is true. 276 into 10 plus current value of n is 5. 5 mod 10. 5 mod 10 results in 5. This is 2760. So that 2760 plus 5. 2765. Then 5 division 10. 5 division 10 integer division. Quotient is 0, remainder is 5. Then when n greater than 0 is checked. 0 greater than 0. What happens? 0 greater than 0. Condition is false. When while loop condition is false, control comes out of steps 4, 5 and 6 because while is controlled in the steps 5 and 6 only. Control comes out of steps 4, 5 and 6. The next executable statement is sequentially given in step number 7. Print yes. So print yes. That means what is the current yes? Current yes is 2765. This is the reverse of the given integer. N is equal to 567. So it seems the algorithm is working correctly. Even if you check for, as I have said in the last session, suppose n is equal to 101. Trace it, sure you will get the same 101. Suppose n is equal to 1005, you will get 5001. Suppose n is equal to 10201, you will get 10201. N is equal to, for example, 500. In this case, your reverse, right? It seems S is equal to 5. There you need to understand this 5 is nothing but 005. These leading digits will not be shown, but anyhow, 500 is reverted to 5. Clear? Have any queries in this algorithm?
No, sir.
So understand the logic. So first, right, I have given the example, right? How do we apply the logic, right, to reverse? So that is given in these slides 1, 2, and 3. Then using this logic, we have designed the algorithm. Then to ensure its correctness, we have traced, right, with one example. You can also write the equivalent, the pseudocode if you want, normal English like statements. Then flowchart can also be constructed easily. Right? Hope you understand construction of this flowchart. So I do not want to write construct the flowchart for this since we have already constructed the flowchart for several examples. We know how to construct for the conditional statement, right? Testing n greater than 0. If the condition is true, subsequently you need to execute the two instructions, steps 5 and 6. When the condition becomes false, control comes out of that. Steps 4, 5, and 6. Finally, we need to print the value yes, then terminate the process. Hope you understand, right? In case if any of you are not able to understand this example, please feel free to ask so that I explain again. Otherwise, I move on to the next example. Okay, I move on to the next example, next topic. Next example that we are going to see is GCD of two integers x and y. GCD, this means greatest common divisor. Greatest common divisor of two integers x and y. Either x or y may be 0. X comma y. X is equal to or greater than or equal to 0 and y is greater than or equal to 0. Suppose take two numbers GCD. You please write mute yourself. I don't know. Please write the switch on. Whenever you have doubt, right, please unmute and speak. Okay, GCD of, for example, we like to compute 10, 52. This is x. This is, for example, y. To find the greatest common divisor of two integers x and y, first you need to write divisors or factors. Factors of x is equal to 10. Then you need to write factors of x is equal to 52. What are the factors of 10? 1, 2, 5, 10. What are the factors of 52? 1, 2 is a factor, 3, not 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. After 13, 14, 15, 16, 17, 26, 52 by 2, then 52. Am I right? Factors of x equal to 10 are returned factors of x is equal to 52 are returned, we need to find the common factors, writing the common factors. What are the common factors? 1, 1, 2, 2. So it seems only two factors, 1 and 2. Sorry, 1 and 2. So from these common factors, the greatest common factor or greatest common divisor, GCF or GCD, both are same. GCD of x comma y, that is 10 comma 52, it seems to us the greatest factor that divides both 10 and 52. This is the basic right example. How do we find the greatest common factor of our two integers x and y? But to find right this operation, we are going to devise the algorithm. There, right, we do not writing the factors of x, factors of y, writing the common factors and finding the greatest in that number. Instead, we can design another logic, GCD of say 10 comma what we have taken a 52. This is x, this is y. Initially, we are performing the operation x mod y. Please understand, I perform the operation x modulus y. What is x modulus y? 10 division 10 modulus 52. 10 modulus 52 results in 10. So when x mod y is greater than 0, I am performing the operations, right? X mod y, this is stored in one variable, say s. S is equal to x mod y. S holds the value 10, that is s is equal to 10. If x mod y is greater than 0, that stage we are performing this operation x is equal to y, y is equal to s. So I write x is equal to 52, y is equal to s, y becomes 10. Repeatedly applying the operation while x mod y is greater than 0, this one. Now, sorry, x mod y is greater than 0, 52 modulus 10, that is greater than 0, 52 modulus 10, this is 2 greater than 0. In this stage, we are performing the operation x is equal to y, y is equal to s. So 52 mod 10, right? This is an s means then x is equal to y, x is equal to 10, y is equal to s. This is actually s. S is equal to 52 mod 10. Now 52 mod 10 is 2. So y becomes 2. Next stage, s is equal to x mod y. 10 mod 2, s is equal to 10 mod 2. 10 mod 2 is 0. When s is equal to x mod y becomes 0, we need to print y as the GCD of given integers x comma y. This is the logic. So take two integers x and y. First find the value of s. S is equal to x mod y. Perform the operations as long as the modulus operation is greater than 0, then assign these executable statements x is equal to y, y is equal to s. Then find s is equal to x mod y. Repeatedly apply this. Once s becomes 0, print the value of y as the GC. For example, I'll take another example. GCD for 12 comma 40. This is x, this is y. Initially s is equal to x mod y, 12 mod 40. This is 12. Since s is greater than 0, I am updating x is equal to y. This implies x is equal to 40. I am assigning s to the variable y. Y is equal to s. Understand, x is equal to y, y is equal to s. Now y becomes, what is y? The value of s. S is 12 mod 40 12. That is reverted. 40 and 12 are actually reverted. Both are same. 12 comma 40 or 40 comma 12. But next stage, executing s is equal to x mod y. Hope you understand. Now s is x mod y, 40 modulus 12. 3 12s are 36. Remainder is 4. S is 4. Greater than 0. So updating x is equal to y. What is y? Current y is this one, 12. Y is equal to s. Y is equal to, current s is 4. Y is equal to 4. Then next stage, s is equal to x mod y. S is equal to x modulus y. This implies s is equal to 12 modulus 4. 12 modulus 4 is 0 because the remainder is 0. 0 greater than 0 condition is false. When the control comes out of these repetition or loop, finally we need to write what I have said. Print the value of y. So once the x mod y becomes 0, print the current y. What is the current y? 12 mod 4. It seems the current y is 4. So y is equal to 4. 4 is the GCD or GCF of 12 comma 40. One can verify the factors of 12. 1, 2, 3, 4, 6, 12. Factors of 40. Sorry, 1, 2, 4, 5, 6, 7, 8, 9, 10. Next 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, then 40. Figure out the common factors 1, 1, 2, 2, no 3, 4, 4, 6, 12, no 6, 12. That's all. In this, the greatest common factor is 4. So we have got the result as 4. This is a simple way to find out the greatest common factor are two numbers, x and y. So now I am writing the algorithm to perform this operation based on these repeated operations, modulus operation and some assignment operations. Please take the algorithm algorithm GCD of x comma y, x and y are integers even x may be 0 or y may be 0. X is greater than or equal to 0, y is greater than or equal to 0. Writing the steps, step 1, start. Step 2, see there are some other algorithms are also available, right? Euclidean algorithm, right? Recursive algorithms, and the extended Euclidean algorithm. Several algorithms are there to find out the GCD. As of now, right, I have said you, right, the simplest way to perform using the modulus operation. You can also find it, right, using repeated subtractions, right. Later you see, right, when we discuss the recursion, that's why, right, I will give you the recursive logic to find the GCD of x and y, because we have one important topic called the recursion in C programming. That's why, right, I tell you how do we evaluate the value of n factorial, GCD, and the Fibonacci numbers using a recursive approach. So as far as now, right? So try to implement it, right? This algorithm. Understand the logic of this GCD version. Input integers x and y. Then step 3. In step 3, what we have to do, we need to check the condition while s is equal to x mod y, this is greater than 0. So shall we write like this, while s is equal to x modulus y, x modulus x modulus y is greater than 0, we need to perform the steps. Perform steps, we write the steps, right, after writing. Step 4. So we are finding s is equal to x mod y. In the two examples, right, we have seen s is equal to x mod y is first obtained. If it is greater than 0, then we have assigned these operations. X is equal to y, y is equal to s. So here checking x is equal to y. Step 5, indentation, some gap, part of this y. Y is equal to s. How long we need to repeat these steps until the remainder is equal to x mod y, this is greater than 0. Or if you have a confusion, you can evaluate x is equal to x mod y before this y as one step. Simply put s is greater than 0. Then after steps 4, 5, in step number 6, you need to write s is equal to x mod y. That is also a correct one. So in this version, right, I write steps 4 and 5. While this condition is greater than 0, after the evaluation of s, that is important. S is equal to x mod y is evaluated first. If this result is greater than 0, that is the meaning of this condition. Then find or apply x equal to y, y is equal to s. Steps 4 and 5. Step 6. In step 6, s is equal to x mod y becomes 0. So when s becomes 0, we need to print a value of y. Print y. This y is the actual GCD of GCD of x comma y. Step 7, stop. Step 8, end. This is the algorithm to find the greatest common divisor or greatest common factor. GCD, GCF, both are same. GCF of x comma y, two positive integers. To trace this, right, let us have one example. Trace the algorithm for x is equal to 12 and y is equal to say 80. The condition to be tested is s is equal to x mod y greater than 0. This is one step. Then x is equal to y, y is equal to s. The value of x is equal to y. Then y is assigning a value s. As we discussed earlier, please write the initial values. Initial value of s. Here there is no initializer. X and y, I take these as initializer. 12, 80. Then control enters into step number 3. X mod y, s is equal to x mod y. I write here 12 modulus 80. 12 modulus 80 is 12 greater than 0. So in this case, right, what happens when x is less than y, the first step x and y are revolved. X becomes 80, right? X is equal to y. That means x becomes 80, y becomes s. Sorry, this is a 12. Y becomes a 12. Then 80 and 12. 80 modulus 12. 7 12 84, right? 6 12 72. 6 into 12, 72. Reminder is 8. 8 is greater than 0. Condition is true. So x is equal to y. This x becomes 12. Y is equal to s. This 12 is reached here. This 8 is reached here. 12, 8. Next, 12 mod 8, 180 is 8, reminder is 4. This is greater than 0. So x is equal to y. Here write 8 and 4 is moved here. 8 and 4. Then 8 mod 4, that's all. 8 mod 4 is 0, greater than 0. Condition is false. When the condition is false, control comes out of steps 3, 4 and 5. That means control comes out of while. Then it executes the next statement, print y in step number 6. So here print y. What is y? Current y. Current y is a 4 here. Y is equal to 4. So that means the GCD or GCF of 12, 80 is 4. You can verify the factors of 12. 1, 2, 3, 4, 6, 12. Factors of 80. 1, 2, no 3, 4, 5, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, right? Then it seems 40, then 8. Common factors, figure out 1, 1, 2, 2, no 3, 4, 4, then 6, 12, that's all. So greatest common factor is 4. So GCD of 12 comma 8 is 4. In case if anyone is 0, GCD of 5 comma 0, what happens? What is GCD of 5 comma 0?
0, sir.
0. Are you sure? Okay, first let us check how the algorithm produces the result. While s is equal to x mod y greater than 0, right? Hope you understand. This is in x, this is in a variable y in our case. While s is equal to x mod y, right? 5 modulus 0. 5 modulus 0, can you divide 5 by 0? 5 mod x modulus y.
No, sir.
No.
Says
So
5
in
is
this
that.
case, what is the answer?
5. 5.
5 or 0?
5 it will come.
What are the factors of 5?
1 and 5.
Yeah, good. 1 and 5. Very good. Factors of 5, 1 and 5. What are the factors of 0?
So any number we can take. Other than 0.
Very good. 0, 1, 2, 3, 4, 5, etc. Yeah, it's other than 0. 1, 2, 3, 4, 5, etc. Common factor is 5, 5 here. So GCD of 5 comma 0 is 5. 5 is expected here. But in our algorithm, right, what happens? The operation x division y, right? This is not carried out. So we need to make a little bit conditional test. If y is 0, x is the GCD. If x is 0, y is the GCD, right? That you need to define here initially. If x is 0, y is a GCD, and if y is 0, x is a GCD. Otherwise, we need to make smaller change. In our case, this equality should be removed. Here x is greater than 0 and y is greater than 0. This case, the algorithm works fine. Otherwise, we need to add the statement before the control logic. I write here GCD of x comma 0 is x, or GCD of 0 comma y is y, or simply GCD of x comma y is x. If y is 0, we can write y if x is 0. So try to implement, right? This is the part of before while loop instructions, so that we will not get this division problem x mod y, 5 mod 0, or if it is 0 mod 5, no problem, right? Only problem is 5 mod 0. That is a problem that can be resolved by adding these instructions, right? Well-defined instructions before the while loop. Otherwise, we need to ensure the input restrictions are x greater than 0 and y greater than 0 initially. Later stage, right, there will be no problem, right, in evaluating the condition x mod y, right, x mod 0, right, will not be the case in the later stages. Hope you understand this algorithm. This can also be converted into the equivalent flowchart representation. So we have seen, right, several algorithms finding the minimum, maximum, odd integer, even integer, factorial, finding the sum of the digits of the number, reversing the number, average of n numbers, GCD or the GCF, greatest common factor. So up to this right, we have explored several problems. We have seen how to devise the algorithms and how to construct the equivalent flowchart and verifying the correctness of the algorithm by doing some trace. Up to this, have any doubts? Have any doubts? If you have any doubts, you can ask. Let us interact.
No, sir, no doubt.
So, shall we move on to the next topic?
Yes, sir.
If we complete, right, two more topics, right, the conversions, base conversions, and then the Fibonacci numbers, then we will be entering into the C language, right, the core C language, so that all the problems can easily be implemented in the C language. So before, right, we start C language, I like to finish, right, complete those two topics. Shall I proceed?
Yes, sir.
Okay, we are moving slowly. If you have any queries, right, you can disturb me, right, in between. So the next one, we are moving to the conversions. For example, 75. Here the base is 10. This is said to be a decimal system or a denary system. Decimal, right? Decimal. Yeah, here the base is 10. Where a binary takes the base to 2. Or to convert from decimal to binary. Decimal to binary. We need to repeatedly divide this by 2 and observe the reminders. Finally, we need to arrange the reminders in the order so that we will get the equivalent binary system or binary equivalent. 75 dividing it by 2, 37 remainder is 1. Then, am I right? Then divide it by 2, 18 into 36, remainder is 1. Then 2, 9 into 2, 18, remainder is 0. Then 2, 4 into 2, 8, remainder is 1. Then 2 into 2, 0. Then 2, 1 into 2, remainder is 0. Now arrange the reminders in this order so that we have this arrangement. 1, I am writing this 1 first, then 0, 0, then 1, 0, then 1, 1. Base is 2. Here, this is in the base 10. So 75 in a decimal system is equivalent to 1001011. in a binary system. To verify that or to convert from binary to decimal, binary to decimal, one zero zero 1011 base 2. This is binary. We need to assign the corresponding weighting factor. This is weighting factor here is this is 2 power 0. Here this is 2 power 1. 2 power 1. The next bit position here the weighting factor is multiplied by 2. 2 power 2. This is 2 power 3. 0 1 1 0 1. Yeah. This is 2 power 4. This is 2 power 5. This is 2 power 6. So simply saying 2 power 0 1, 1 into 2 2, 2 into 2 4, 4 into 2 8, 8 into 2 16, 16 into 2 32, 32 into 2 64. Likewise it goes on. These are the corresponding weighting values. This should be multiplied by the equivalent binary bit, either 0 or 1. Now if you write 1 1 0 1 0 0 1, this is equivalent to 1 0 0 1 0 1 1 base 2. This is equivalent to writing this, right, 1 into 64, or you can write 1 into 2 power 6. I write directly 1 into 64 plus 0 into 32 plus corresponding digits are multiplied, right? 1 is multiplied with the 64. Then the bit 0 is multiplied with value 32. Then 0 into 16 plus this 1 into 8 plus this 0 into 4 plus this 1 into 2. Finally, this 1 into 1. Understand? This is the conversion from the binary to the equivalent decimal. This is equivalent to 64 plus 0 plus 0. Then next bit 1 into 8 8 plus 0, then 2 plus 1. 64 plus 8 is 72, 74, 75. So the equivalent decimal number, right, 75. This is obtained in the reverse conversion. Here we have obtained the binary conversion in the forward order, decimal to binary. In the reverse conversion, we need to multiply the bit position with the equivalent, the weighting values. So how do we define from binary to decimal? Starting from right to left. The place values are 2 power 0, 2 power 1, 2 power 2, 2 power 3, etc. This goes on. But in the case of a decimal to binary conversion, we need to divide the numbers repeatedly by 2 and record the reminders like this. Then the reminders are going to be processed this order, reverse order, so that we have the equivalent binary number. Likewise, decimal to octal, right, where the base is 8. Decimal to hexadecimal, right, where the base is 16. The decimal to right quinary, right, the base is 5, right. Those conversions are also going to be carried out. So here, right, you need to think of when the decimal number is given, how do we find the equivalent binary number, and when the binary number is given, you need to think of designing the algorithm convert in to convert it to the equivalent decimal number. So you try to design the pseudocode, flowchart, algorithm, right, and verifying the correctness for this conversion, binary to decimal and decimal to binary. Next, I am moving on to the topic Fibonacci numbers.
Sir, I have a doubt, sir.
Yes,
Hello.
tell me.
In the
Yes,
division, when before slide, sir,
yeah.
in this, there is 18 minus 1, no? What happens after that? How does that 1 become 0, sir?
Which one last stage? 80?
No, no, sir. Like
Are you asking?
75, 75, then
Yeah,
37
okay. Yes,
minus 1,
70.
then 8.
Yeah. Wait. I explain. This is 75. 75 is divided by 2. 37 is the quotient. 37 into 2. 74. What is the remainder? Remainder is 1. So
1.
37 it's not minus 1. We have written in this format. Quotient hyphen remainder format. 37 1.
Oh,
Then
okay.
further
I
37
thought
is
it was
divided by
something.
2. No, not 9. So okay. 18 into 2 36. Then the remainder is 1. Q hyphen R format. This is quotient a remainder. So as of now, I try to
Okay,
devise
sir.
a logic. Later, right, after discussing the concept of arrays, right, control statements, we will revisit this problem so that we can easily implement the solution, right, in the C language. Likewise, in the reverse process also, we can easily find the total number of binary digits. That means we mean zeros and ones. Once you find the number of digits here, 1, 2, 3, 4, 5, 6, 7. Am I right? 7 bits are there. 1, 2, 3, 4, 5, 6, 7. Having these 7 bits, the arrangement is like this. First bit into this is 2 power 7 minus 1, that is 2 power 6. 2 power 6. Then this is 2 power 5 weightage, 2 power 4, 2 power 3, 2 power 2, 2 power 1, 2 power 0. Later in the C language, right, we implement this easily. We need to find the total number of ones and zeros in the given binary. Based on that, we can find, right, what is the upper weightage value, or 2 power L minus 1, where L represents the total number of bits in the binary equivalent, so that we can easily perform these arithmetic operations, right? 1 into 2 power 6, 0 into 2 power 5, then 0 into 2 power 4, plus etc. Finally, 1 into 2 power 0. Next, we are moving on to this topic here, the Fibonacci sequence. The sequence is defined, right, according to Fibonacci. The integers are forming the sequence. Two initial values are required. These are 0 and 1. Having this initializer 0, comma 1, we have the sequence of numbers according to Fibonacci. How do we find that sequence? Initially 0 is returned, then 1 is returned. The next number is added with 0 and 1. Right? Next number is formed by adding 0 and 1. 0 plus 1. This is equal to 1. This is the next number. Then the next number is, this one is formed by adding the previous two numbers. I write here. Likewise, the next number is formed by adding the previous two numbers, right? This one and this one. Adding this one and this one, we have 1 plus 1 is equal to 2. Then adding, right, the previous two numbers, 1 plus 2 is equal to 3. Then 2 plus 3 is equal to 5. Then 5 plus 3 or 3 plus 5 is equal to 8, etc. So clearly the sequence is defined, right, like this: 0, 0, 1, 1 plus 0, 1, 1 and 1, right, 2, 2 and 1, 3, 3 plus 2, 5, 3 plus 5, 8, 5 plus 8, 13, 13 plus 8, 21, 21 plus 13, 34, 34 plus 21, 55, etc. This is the Fibonacci sequence, right? The sequence is formed according to Fibonacci. 0 and 1, right? These are initial values. Using this, the next one is obtained. The 2 is obtained by adding these two numbers. Then 1 plus 2, this results in 3. Then 3 plus 2 results in 5. This way the sequence gets formed. Understand the logic?
Yes, sir.
We can design the algorithm to print this sequence. So to print this sequence, we need two initializers or two initial values, 0 and 1. These can be stored in some variable, say a and b. A is equal to 0, b is equal to 1. Next integer, right, should be obtained based on these initial values, and subsequently we need to use the variable, say sum a, b, iteratively applying the operation. The subsequent numbers in the sequence are going to be applied or obtained. So I write here, suppose this is stored in a variable a. A is 0. This is initialized in a variable b. A is equal to 0, b is equal to 1. This is the value c obtained by adding the variables a and b. C is equal to a plus b. Next, to find out 2, we need to add b and c. We are not going to incrementing the adding the variables, right, by incrementing the number of variables, not incrementing the number of variables. We don't want to put this as a d, not d is equal to b plus c. Instead, once we have these three variables, b, c is equal to a plus b, next stage, shall we have this as a and this is B. That means we are updating B and C into A and B. Since 2 initializer is enough to find out the next value. So in case if A is 1 and B is 1, next this is obtained as same operation, C is equal to A plus B. Now 1 and 2, right? This is B, this is C. So next this B gets updated to A and this C gets updated to B, so that this 3 is obtained as C is equal to A plus B. So only the variables A, B and C, these are enough. Once we find a new value of C, then we are updating the variable A to B and B to C. Iteratively, we are continuing the process to print the equivalent numbers or the sequence, Fibonacci sequence. Understand the logic? Any doubt in this logic? How we are forming the subsequent numbers?
Sir,
Yes.
sir, can I explain this again?
Okay. Initially, right, we have the two numbers 0 and 1. 0 and 1, we have two numbers. The next number is obtained by adding these two numbers. Adding 0 and 1, we have the number 1. Then the next number is obtained by adding the previous two numbers 1 comma 1. 1 comma 1, this results in 2. Then next number is obtained by adding this 1 and 2. 1 plus 2, 3. Then 2 plus 3, this results in 5. 5 plus 3 results in 8. 8 plus 5, 13. That's what we have the sequence 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55. For example, we have written some numbers in that sequence. Clear?
Sir, this is like I'm clear with this, sir, but I'm not clear with the algorithm, sir.
Yeah, good question. For that, we are setting A to 0. Initially, we set A to 0 and B to 1. A and B are the two variables which are initialized to 0 and 1. Just ignore the remaining numbers. Concentrate on the third number alone up to this. The third number, the C is obtained. This is C. C is obtained as A plus B. 0 plus 1 results in 1. Hope you understand up to this. These are initializer. One-time initializer. After these initialization, we are finding the next number C as adding the current values of A and B. Then C can be printed. To find out the next number 2, we need to add these 1 and 1. These 1 and 1 are actually stored in the variables B and C. Every stage, to find or simply to print a new number, we need the previous two numbers. Previous two numbers are going to be stored conveniently in the variables A and B, so that iteratively we can use the same statement C is equal to A plus B. As we have seen, right, in the reverse algorithm, sum is equal to sum into 10 plus n mod 10, like that. We like to use same assignment statement C is equal to A plus B everywhere. So next, to find this 2, what I am going to use, please understand, I am using the same statement C is equal to A plus B. To find out this 3, I am using the same statement C is equal to A plus B. To find out this 5, the target is to use the same statement C is equal to A plus B. But A and B are going to be updated accordingly. Currently, A and B are 0 and 1. Because of that, C is equal to A plus B results in 1. Up to this is okay. Next, to find 2, that is, after finding C is equal to A plus B, I like to use the statement print C. I expect 2 to be printed and the execution of C is equal to A plus B. But previous 2 numbers are currently held in the variables. This is B, B1 and C1. Hope you understand. Now, what I am going to make, before this C is equal to A plus B, I like to store this B into a variable A. So, shall I write here A is equal to B, and this C, this is updated into a variable B. So, shall I write B is equal to C? If I write A is equal to B, B is equal to C, what happens? This is the new value of A. So to find true, I am updating this one into a new variable A, this one into a new variable B. So A and B are already declared, so we are using those variables, but this 1 and 1 are updated to the variables A and B. That is the meaning of this A is equal to this B. This B is equal to this C. A is equal to B, B is equal to C. So clearly, to find this C is equal to A plus B, what is the current A? 1. What is the current B? 1. 1 plus 1, C is equal to 2 is obtained. So this 2 is obtained. Clear? Clear or not?
Yes, sir. Thank you, sir.
Understand or not? Okay. Good. Next,
Sir.
to find this 3, okay, I explain. To find this 3, I am using the same statements. What are the statements? A is equal to B, B is equal to C, C is equal to A plus B. So I write the same statements here. A is equal to B, B is equal to C, C is equal to A plus B. That means previous 2 numbers are updated to A and B. So up to this 2, right, we have stored in a variable C. C is equal to 2. Previously, right, this is A and this is B. But to find this 3, 1 and 2 are required. This 1, right, is updated into a variable A. This 2 is updated into a variable B. That's what A is equal to B, right? Then B is equal to C, so that 1 plus 2, this results in 3. C is updated in. Next, writing the same statements, A is equal to B, B is equal to C, C is equal to A plus B, we will get this resultant value, right? 2 plus 3, 5 is obtained. Then 2 plus 3, 5, this is C, this is B, A is equal to B means this is updated in a variable A. B is equal to C. This is previously C. The C gets updated to B. So that C is equal to A plus B. 3 plus 5, 8 is produced. This is the logic to find out the subsequent numbers in that sequence. So we can write the simplest level of algorithm. Here, let us write algorithm Fibonacci sequence. Let us try to print some numbers in that sequence. So how do we write? Step 1, start. Step 2, we need to think of how many numbers are required, right? For example, if you restrict n is equal to 7, 7 numbers you need to find. You can assume the problem in any way. For example, I include 0 is the first number, 1 is the second number, then 1, 2, 3, 5, 8. How many numbers are? 1, 2, 3, 4, 5, 6, 7. Yes, n is equal to 7. If you state a problem like this, n is equal to 7 numbers are going to output 0, 1, 1, 2, 3, 5, 8. 1, 2, 3, 4, 5, 6, 7. 7 numbers are output. In this case, you need to get the value of n, which defines the number of numbers in that sequence to output. So in this example, I like to get the value of n. Suppose n is equal to 10 is given. 10 means already 7 numbers are there. Then this is the 8th number, this is the 9th number, this is the 10th number. These 3 numbers should output 13, 21, 32. So this way, right, we are assuming the value of n, input n which defines the number of, say, integers to be printed. Step 3, we can print, right, initially A is equal to 0, B is equal to 1. So we can try to write to reduce the space. I write A is equal to 0, B is equal to 1. Initializing the two numbers, A is equal to 0, B is equal to 1, and I make a count. Say, is it visible? Count. This is count is equal to 2. Since two numbers are initialized, for example, I initialized the count as 2. Since n numbers are required, 2 numbers are here, there. So in step number 4, print
Sir,
A comma B. So 2 numbers are, yes.
sir, can we also use the while function for this sequence?
Can we use?
While function.
Can we use which function? Yeah,
While
while.
function,
We can
sir.
also use while. While for, yes, while for whatever you need, right? You can use.
Okay,
Print
sir.
A
Thank you,
comma
sir.
B. First two numbers are printed here. Good. Then step 5. If you want, right, you can use a for, or you can use a while loop. For example, as you said, I write while. While, how many numbers should be printed? N numbers will be printed. We have printed 2 numbers. Out of n numbers, 2 numbers are printed. N minus 2, right? Numbers yet to be printed. Hope you understand. Total numbers, right? Total number of integers to be printed is n. A is equal to 0, B is equal to 1. Since we assume these are also the Fibonacci sequence integers, I have, right, set a count to 2. A and B are printed. So while here what I can write, count less than or equal to n, perform the steps or repeat the steps. Perform, sorry, perform the steps. If we fix the steps, right, next after writing. Step 6. For loop, while loop, right, are also same, right? I can use any one. Count less than or equal to n. Now what is the count to 2? Say 2 less than or equal to 7. Condition is true. 2 numbers are printed. You have to find n minus 2. Suppose n is 7. N is 7. 7 minus 2, 5 numbers yet to be printed. That is the logic. Now when count is less than or equal to n, having A and B, first find what is C. What is C here? What is C here? C is equal to A plus B. Am I right? Currently we have the variables A and B. So next number to be obtained is clearly C is equal to A plus B. So first find what is C. C is equal to A plus B. Then print a value of C. So shall I write? Okay, I need next page. Step 7. If you want, you can write print to C in the same step also, or write print to C in step number 7. I need to continue in the next page, so I write here step 8. Find A and B are assigned. C is equal to A plus B is computed. Immediately C is printed because we need this sequence when n is equal to 7, 0, 1, 1, 2, 3, 5, 8. This is the expected output. This sequence should be printed. 0, 1 is printed. After this computation, C is equal to A plus B, right? So this 1 is stored in a variable C. These are stored in a variables A and B. Okay, this is visible. This is A, this is B. C is equal to A plus B is computed. 1 is printed here, right? Print to C, 1 is printed. Then we need to update the variables A, B, that's all. So writing A is equal to B, B is equal to C, as we constructed earlier, please look into here. A is equal to B, B is equal to C, A is equal to B, B is equal to C, A is equal to B, B is equal to C. Since C is equal to A plus B is obtained, right, once A and B are fixed, I do like to write step 8 as the part of while block. So I leave some space in step number 8. I write here A is equal to B. Step 9, I write B is equal to C after leaving some space, right, as a part of while block. A is equal to B, right, B is equal to C. Yeah, okay, A is equal to B, B is equal to C. These are included repeatedly in our while block. Then step 10, can you predict, right, what we need to write in step number 10? Am I right? 1, 2, 3, 4, 5, 6, 7, yes, 8, 9, 10. So while count is less than or equal to n, perform the steps. Print, find the value of C, print to C to be included. So steps 6, 7, yes, included. Then updating the variables A and B. 8, 9, right? S included. 6, 7, 8, 9. Or in short write, you can write in algorithm. Perform the steps 6 TO 6 to 9. You can also write like this in short. Because many steps we need to perform, not necessarily to write the numbers, continuous numbers, just specify the range, right? Like in English, 6 to 9, starting from 6, 7, 8, 9, up to 9. Okay, if the condition is true, count less than or equal to n means the nth number is obtained. We check it after tracing the steps, right? Next. So as of now, what is expected in step number 10?
Sir, count is equals to count plus 1 we have to do.
Very good. Count is equal to count plus 1. That should be done, right?
Yes,
Next.
sir.
That should also be the part of while block. Because if not, count remains 2. Unexpectedly, count is 2, 2 less than or equal to n, 2 less than or equal to n, 2 less than or equal to n. That means we'll get infinite cycling operation. Infinite times we will be finding the value of the integers in that sequence. So to avoid that, we need to have exactly count number of integers or n number of integers. So count less than or equal to n. N indicates the total number of integers to be output or to be printed. Hence, count is equal to count plus 1. Very good. That is the part of the while block. I write count is equal to count plus 1. So what are expected here? Perform the steps 6, 7, 8, 9, 10. So here write 6 to 10 in short. Perform the steps 6 to 10, or an English statement you can modify. Repeat the steps from 6 to 10. Repeat the steps from 6 to 10 as long as count less than or equal to n is true, or repeat steps from 6 to 10 while count is less than or equal to 10. Both are same. Or as usual, you can write while count less than or equal to n hyphen perform the steps from 6 to 10. So once the integer c is printed, count gets incremented by 1. That is the meaning of count is equal to count plus 1. After this increment, count becomes, say, for example, c is equal to a plus b. Here in this example, c is equal to a plus b. Now, count becomes 3 after printing c, because here count is equal to count plus 1. Next, count is 3. 3 less than or equal to, 3 less than or equal to n. That stage, what happens? C is equal to a plus b. Now, C, A and B are updated, so the next number is printed. This number, right? 2 is printed, 3 is printed, 5 is printed, 8 is printed. You need to check exactly while count less than n or less than or equal to n. That you need to check, right? That should be verified by doing the trace. So as of now, okay, steps 6 to 10 are okay. Then what is step number 11? Can we predict? Can we predict what is step number 11?
Stop then end, sir.
6, 7, 8, 9. Very, very good. Because 6, 7, 8, 9, 10. These are the part of while. Step 11 is stop. Step 12, end. This is the procedure or algorithm to find out n Fibonacci numbers or to print n integers in that sequence. Let us check, right, by taking a small n, right? to check if count is less than or equal to n, or while count less than n to be put. Shall we take the value of n? Suppose n is equal to 5, the smaller n is taken. So when n is 5, right, initially a is 0. Shall we do the trace? This is the trace. Let us complete the trace for n is equal to 5 within few minutes, so please wait. A is necessary, B is necessary, then count less than or equal to n, that we need to check. Count less than or equal to n, then C is equal to A plus B, then A is equal to B, B is equal to C, that we can use the columns, right, for the first to A and to B, then print to C, before that, right, here A and B are printed, right, so I exclude that statement A and B, print A and B. Okay, let us start. N is equal to 5, A0, B1, count to 2. Please understand, this is simple to ensure the correctness. A0, B1, what is count? Count is 2 initially. Here I write print AB, so I mean 0 and 1 are printed initially. So before the while loop, A and B are printed, I have written here. Next, control enters into the while loop, while count is less than or equal to n, n is 5, so I write clearly here, please understand. 2 less than or equal to 5, am I right? Count less than or equal to n, 2 less than or equal to 5, condition is true. If the condition is true, what are we going to assign? C is equal to A plus B, print to C. So C is equal to A plus B means this current 0 and 1. 0 plus 1 is equal to 1. Print to C, 1 is printed. So here print to 1. 3 numbers are printed. Then after print to C, A is equal to B, B is equal to C, count is equal to count plus 1. A is equal to B means A receives this 1, B receives this C, B is equal to C. Then count becomes count plus 1. So I write in the next step, count is count plus 1. Count becomes, what is the current value of count? Count is currently 2. Yes, this 2 is updated to 3. 2 is updated to 3. Next, carefully go through the steps. After the execution of step 10, control goes to step number 5. It checks if count is less than or equal to n. So I write count is less than or equal to n. Current count is 3. 3 less than or equal to 5. Condition is true. If it's so, find C and print C. C is equal to A plus B. Current A and B are 1 and 1. I write here clearly 1 plus 1 is equal to 2. Then print to C, step number 7. Print to C, so 2, here I write, for example, print to 2, or 2 is printed. Then step 8, A is equal to B, B is equal to C. So I write here A is equal to B, update. A is updated to 1, B is updated to C. So this is 2. Sorry, this 2 is assigned to here. A and B are updated. These are the new values, 1 and 2. A and B are updated. Count gets updated, count plus 1. So count becomes 4. I write count is in the next line. Count is 4. Then control goes to execute. While count is less than or equal to n, 4 less than or equal to 5. Condition is true. If the condition is 4 less than or equal to 5, condition is true, find C, print to C. Find C, 1 plus 2. From these, 1 plus 2 is equal to 3. Print C, 3. I write here. Print 3. Then what happens? What happens next? Count is incremented by 1. Count is equal to count plus 1. A is equal to B, B is equal to C. Count gets updated. What is the next count? Current count to 4 less than or equal to 5. Next count gets updated. Count becomes, this 4 becomes 5. Next entry condition is 5 less than or equal to 5. Before that, check how many numbers are printed. Since n is equal to 5, 5 numbers are 0, 1, 1, 1 plus 1, 2, 2 plus 1, 3. Am I right? This is the sequence to be expected. 0 and 1 initially printed. After finding C is equal to A plus B, this 1 is printed. Here, 0, 1 initially printed, 1 is printed, or 2 is printed, 3 is also printed, 1, 2, 3, 4, 5. Since we fixed n is equal to 5, 5 integers are expected, that's all. So you need to change, right? Next, n less than or equal to 5, this equality should be removed. Hope you understand. That's what I said earlier. So removing this equality, strictly have the inequality, count is less than n. Here also, count is, where is, okay, count is strictly less than n. Check every stage, count is less than n, 3 less than 5, 4 less than 5, 5 less than 5. Next stage, when count gets incremented, we need to check if 5 less than 5. After finding C, print to C, AB, BC, count is equal to count plus 1, right? Here we need to update the value, right? Checking if 5 is less than 5, when the condition is false, control comes out of this block, so that next statement is stop and end. So clearly we have printed 5 integers, right? So you please check it again by taking some small values. So n is equal to 8, 9, 10, like that, and try to do the trace and check it, right? This less than relationship works correctly. This is Fibonacci sequence. Have any doubts? Have any doubts?
No, sir.
No, sir.
Okay, please go through the session. I share the materials, right, including PDF file and video file after some time. Please go through the session, right, again carefully, so that if you have any queries, right, you can ask me. Okay, prepare well, right. Thank you very much.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.